So the question, a proposed 5-meter long internal column in a rigid jointed steel or in a rigid joint steel structure, is to be loaded concentrically with 1,200 kilonewton dead load and 1,000 kilonewton live load or imposed load. Full stop. Assuming that both ends are fixed. Assuming that both ends are fixed. Assuming that both ends are fixed. And preventing any rotation. And preventing any rotation. Design column sections. After that rotation, comma, design column sections. Design column sections. Assuming the structure will be. Design column sections. Assuming the structure will be A, braced, B, unbraced. Full stop. I said, assuming that both ends are fixed and preventing any rotation. Design column sections, assuming the structure will be A, braced, B, unbraced. Now, let's start. What's our first step? What's our step 1? Please read it out to me. Good. Now, to determine your ultimate axial load, are you with me? FC. The formula is, for your design load, what is the formula for your design load from concrete and timber? 1.4 GK plus 1.6 QK. So that's the same thing here. 1.4 GK plus 1.6 QK. Now, what's our GK? What's our GK from the question? GK is what? No, what is the meaning of GK? Dead load. So what's our dead load from the question? Good. What's our QK? So what would be the value for your the value of your FC? What's the value of your FC? You didn't bring calculator to a steel design class. What's the value for FC? All right. For the sake, I'm teaching you people, so I'll just be giving you an answer. I can't spoon feed you. It will fail, like I'm saying, so you will restart it yourself. What's the unit? Kilonewton. Do you understand that? What does your step 2 say? Your step 2 says what? Select trial section. So what I'll do is trial section 1. Now this trial section, what I said is, for people that are just coming, in section classification, what we did last week, they gave you your section 305 by 305 by something you see, right? But in questions like this, you see from this question, from this topic onwards, they will not give you your section. You'll be the one to give yourself your section. So if you design using that section and it fails, you redesign again using another section. If it fails, you can do it like 9 times. You can do it like 6 times. If you are lucky 2 times, you are lucky 3 times, and it will pass. Are you with me? So what I'm saying is, this particular section I want to give you will fail. I know it will fail. That's what I'm giving. That's why I said you should give your BS code and your steel table so that you pick your own section and we'll see if it will pass. Are you with me? Yeah. So now take down this section 254 by 254. Trial section 1. So my trial section 1 is, what type of compression member am I doing? A column now. So that's what UC. 254. What's the meaning of UC? Universal column, good. 254 by 254 by 107 UC. Where am I picking it from? Where do I pick sections from? Where do I pick it from? My section table or my steel table, right? Good. So what's your question? Why will I tell you? You don't know where to pick section table from. Now, trial section what? 1. I picked my thing. So if you are solving, you'll be the one to pick your section yourself. Good. Now, what does it says that you should check what and check if it is what? What's that step 2? Check if it is non-slender. Let me re-explain what I said. When something is non-slender, what is class 1? If you are classifying, class 1 is what? Plastic. Class 2 is what? Class 3 is what? Semi-compact. Class 4 is what? Slender. Now, what is saying that you should check if it is what? Non-slender. Meaning it should pass class 1 to what? 3. But it must not exceed class 3. That is, it must not enter class 4. Now, in this case, I will not classify. You are meant to classify. Let me tell you why I will not classify. In the mass PDF, the way it classified was wrong. Right? And I do not want to teach you people any wrong thing. So, in these questions, there are a lot of assumptions, there are a lot of things that we need to question. So, the classification of these parts, I will not explain it because I am not clear of it. Do you understand? Are you with me? So, these are questions that we need to ask the man. Okay? Do you know how to use the steel table? Now, we are doing what? Universal column. So, where will you go to in your steel table? What does UC mean? So please, everybody should open this trial section. Open this trial section in your steel table. Yeah. You are going to use both. What's the first one? Dimension. Go to your dimension. Good. Now, I said I will not what? I will not classify. So what's step 3?
Step 3, determine Rx, Ry, and Ag from the steel table.
What is step 3? This is a class. Please answer me as a class.
Ry, Rx, and Ag from the steel table.
So step 3. Now, I'll call individual people. Like, I'll call you one after the other. Why? Because I want to be sure that you know how to use steel table. I want to be sure you know how to use steel table. Now, are we all in this class, first of all, before I call anybody? Hello? Are we all in this class? Now, Edoka, please pick your, what's your radius of gyration for your x-axis? Be there, I'm waiting for you. Are you in? I'm waiting for you, please. If you do not know it, please don't let us waste time so I can move on to someone else. You see why I said you need to print this thing? See, it makes no I'm not even laughing. It makes no sense for you to be using phone to check what you can easily open like this. Print this thing if you want to be attending this class. Is that right? Someone should help him out. What's RX? So we can move on, please. What's your RX? 11.3. What's the units? Centimeter.
But generally, some of those use dimension, but dimension does not have the area of direction and the radius of direction. That's why I meant.
Steel table encompasses what? Dimension and properties.
Also making it better.
What's RX? What's RX?
6.59.
What's RX?
11.3.
Why are you telling 6 point?
I thought you said RY.
254 by 25. Don't worry, let me check it. 11.3, yeah. So my Rx is what? 11.3 what? Centimeter. What's my RY? 6.59 centimeter. And the last thing you want to check is what? AG. So what's AG? What's AG? 136 centimeter squared. What's the next step?
Determine the effective length and
Determine the what?
effective length.
Please, are we all in this class? I'm asking for next steps. Say it now. Using what? So please, let's go to our table 22. Oh yeah, start swiping. Start swiping now. If I say table, where are you going to? Good. So what's your question that from where? Table 22 in your BS code. What's the heading? Good. Now, I'm going to walk you through the table. Are you with me? I want to believe you are all in the table, you are still swiping. Now, it says A, hello, one house. One house. A, non-sway mode. Listen. Listen. Can you see where it says non-sway mode? Now, your non-sway mode is the same thing as braced. Your braced columns do not sway. I think we all know this, right? Braced columns do not sway. One house. Please, one house. Non-sway mode is what? Braced columns. Sway mode is what? Unbraced. Please, I have explained this thing. I will give you another question now. It will be unbraced. I know some people use braced for me. I know. I'm explaining now. Write it in your notes. Non-sway mode is what? Braced. Sway is what? Unbraced. Good. Now let me take it one after the other. So it says restraint in the plane under consideration by other parts of the structure. Now let's start. Hello. Effectively held in position at both ends. Are you there? Effectively restrained in direction at both ends. Are you with me? Effectively restrained in direction at both ends. He's saying fixed at both ends. Write it down. That first line is telling us fixed at both ends. Because in your question, they will not tell you that it's restrained at, they might just tell you fixed at both ends. It depends on how the lecturer wants to set it. But I'm interpreting it for you now so that you can write it down. And if you think your head can carry it. Your question now, go back to your question. You say you should solve for what? You say you should solve for what? Good. Now, there are actually some questions that they will not tell you braced or unbraced. Are you with me? So there are different ways they can tell you that this thing is braced, this thing is unbraced. Number one, they can tell you it will sway. If they tell you to sway, it will be what? If they tell you it will not sway, it will be what? And now there are some questions they will not even tell you that. They'll just not say anything. Now, if a question is braced, it will always be stated. If it is not stated, just take it as what? Unbraced. First look at, read that question very well. Read the question very well. Check if they did not say sway mode. Check if they did not say non-sway mode. Before you now choose that it is what? Unbraced. Are you with me?
Yes.
Good. So now back to the table. Effectively restrained in direction at both ends means fixed at both ends. Partially restrained in direction at both ends means one end is fixed and the other is pinned. Is pinned. One end is what? Fixed and the other is what? Pinned. Please write it down. The third one is restrained in direction at one end. That one means one end fixed, the other is free. The first one means what? This is a fixed at both ends column. The other one says what? The third one says what? Now the last one says not restrained in direction at either end. Means both ends are pinned. Please, I explain this thing. No, it's not be that I'll give you a question. You'll be asking me which formula for effective length will I use. Now we are solving for braced. You know, this question says we should do what? Braced and what? Unbraced. But it's A is braced, right? So we are solving for braced. So what formula will we use? 0.7. Read your question very well.
Yes.
So 0.7 what? What would that give you? So step 4. Our effective length, LE. Now, in this case, both LEX and LEY, they are the same thing. Right? Because you have only one length. Are you with me? You know, in your step 4, it says you should find what? Effective length, LEX and what? LEY. But in this question, you have just one length. So your LEX, your LEY is the same thing as what? LE. Are you with me? So that's 0.7 what? L. What's our L? If you are calling it 5, what will be the unit? Meter. So what will be the 0.7 times 5 will give you what? 3.5 watts. Good. So do you understand up to this point? Do you understand up to this point? What does step 6 say? Step 5. We are in step 5? Which one is effective length that we just finished? I said what's step 5? Oh, sorry. Step 5. Determine what? Slenderness ratio. What's the formula? Please, one house. And I said our LEX in this question is the same thing as what? And it's the same thing as what? Our LE, right? So what's the unit of our R first? Centimeter. Now, we are going to convert it to what? We are going to convert it to what? Millimeter. This our LE2, we'll convert it to what? Millimeter. Now, when we are doing this thing, we try to work with what? Sometimes the smallest. Millimeter is the smallest now, right? So, what's our LEX in millimeter? What's our LEX in millimeter? Yeah? Now, this RX, okay, which one are we doing first? RX. Convert RX to millimeter. What we have? You have 113. Centimeter to meter is times what? Centimeter to millimeter is what? Times what? Times 10. What will this give you? What will it give you? 30 points. 30. 30.97. It is unitless because L is what? Mm. RY is what? Mm. If you cancel each other. Are you with me? Are you with me? Should I come again? Should I come again? Slenderness ratio is equals to LEX. For the one for x-axis is LEX over RX. The one for y-axis is LEY over what? RY. In this question, we have only one length, meaning both our LEX is the same thing as our LEY is still the same thing as our LE. So now our LE, we got the answer in what? Meter. Our what's it called? Our RX is in what? 11.3 what? Centimeter. It's easier to convert both of them to what? Millimeter. But if you want to do it, it's your choice. So are you with me? Since this one is in centimeter, you just convert this 3.5 meter to what? Centimeter. We'll still arrive at the same answer, right? Are you with me? Do you understand what I just said? What I did is that I converted my 3.5 meter to what? Millimeter. I converted my RX to what? Millimeter. To arrive at 30.97. What I'm saying is if you want to convert it to centimeter, because this one is already in centimeter, so you just convert this one to what? Centimeter. We arrive at the same what? Answer. Are you with me? Now, let's do our slenderness ratio for our y-axis. What would that give you? So this is still what? 3.5. What's our RY? 65.9. What would this give us? 53 point what? Do you understand to this point? If you don't understand, please call me back now. If you don't understand, please call me back now. All I did in that place is conversion. What's your question? Why? Because in this question, we have just one length. One length works for both axes, x-axis and y-axis. So that's to tell us that whatever we get for our LE, are you with me? It's the same thing as our LEX and our LEY. Do you understand? Any other question? Moving on. Who is that? What's step 6? What is step 6? Please, let's go to table 23. Now, I need each person with their own BS code now. Me, I don't know how you want to do it too. Please open your BS code because you need to see this particular table has like 9 pages. How to explain how to use each table. Table what? Print BS code. You had 1 week. That's why I did the tutorial on Saturday. Oh yeah? Table what? Please go to your table 23. Now, table 23. Are you all there? Are you all there? Please, it's not the front row I'm asking. Are you all there? Should I move on without you people? Are you in table 23? Good. Now, it says type of what? Section. Universal column is what type of section? Universal column is what type of section? Road what? Road H section. Did I tell you in last class or not? So if you're asking me how did I get it, I don't know how I want to tell you again because I'm very sure I told you in the first class. Now, road what? H section. So you know you are working with that what? That row for what? Road H section. Now, the next column says maximum thickness. Maximum thickness. How do you find your maximum thickness? Settle down. How do you find your maximum thickness? Thank you. How do you find maximum thickness? Now, please, what's your maximum thickness? Check your table for me. I will not go back to some things again. The fact that you people don't even have DS code and you don't have steel table, I don't know how I want to help people. What's your maximum thickness? Eh? Who says 0.5? So now, I'm explaining what each column means in this table. We already understand which type of section we are dealing with. Yes or no? Yes. We understand the maximum thickness now. Yes or no? Yes. Who said no? Who wants to explain how we got our maximum thickness? I'm going to call now. Please explain. Someone has already. Oh yeah, explain. Hello. Good. So you have small letter T and capital letter T. One is for flange and one is for web. Which one is for flange? Which one is for web? Big T is for what? Good. Now, your maximum thickness is the highest value between those two T. Are you with me? Are you there now? Do you understand it now? Have you seen it? Good. Any other question? What's your question? You don't understand what? One house, please. One house. You don't know how I got it? That would be another. That's what I just finished explaining. Do you know?
I know, like
It's the what?
Yes. When is that? No, you are putting you. I think from last class. Are you considering this?
Hello. One house. What's your question?
Are you considering this trial section?
Yes, that's what I'm considering. Now, moving on. The third column says axis of buckling, XX and YY. Now, I told you that we are solving for how many axes? Two axes, right? XX and YY. That's like everything we have been doing. Everything we have been doing is what? X-axis, Y-axis. X-axis, Y-axis. Are you with me? Now, let's go to that rule for road H section. So our maximum thickness is what? 20.5 mm. So the first one says lesser than, that is your maximum thickness, is it lesser than or equal to 40? Yes. Is your maximum thickness lesser than or equal to 40? Yes. So, are you there? Yes. So, for XX, your answer will be what? B. So, you write it out. You will see what it means when you get to, you use it on that table. Hmm? I see. Let me make something very clear. Next class, no BS code, no steel table, you are not entering. You will not even see. You will enter, but I will not go back. Deal. Because some questions that you're asking me, if you're actually with steel table, you will see it. If you are with BS code, you will see it. Now, I'm going to come again. Look at that axis of buckling. First of all, let's look at that rule for road H section. Are you with me? Maximum thickness. Our maximum thickness is what? 20.5. You have two cases for that road H section. You have lesser than or equal to what? 40 mm. And greater than what? 40 mm. Now, what it is saying is your maximum thickness lesser than or equal to 40? Or is it greater than 40 mm? In this case, which one? So do you understand now? So our axis of buckling for x-axis is what? For our y-axis, what's our axis of buckling? For our y-axis, what's our axis of buckling? Do you all understand to this point? The next step, we are going to interpolate. You all remember how to interpolate, Abi? Now, I'm not going to teach you how to interpolate. Beside yourself, you understand how to interpolate, so please explain to yourself. I'll give you 5 minutes for that when I reach there. Or let me just do your first interpolation for you. Up to this point, do you understand? Up to this point, do you understand? Who is saying no? What's your question? Ask your question. This thing will fail. You know, I said it from the beginning. What we are solving will fail at the step 9. You go resolve all of these that we are doing. You still resolve. You do it here. It's not that you go. You will do it. Yes, you do everything again. Each step. Yeah. Good. Now, practice makes perfect. Hello, one house, please. One house. What's table? I said table. What step is this? This step 6, Abi. Yeah. What's step 7?
Step 7, determine compressive strain. Using table 24.
Please go to table 24. Now, look at this table 24. Are you with me? Look at this table 24. Table 24. Are you with me? Now, are you all there?
Yes.
Your lambda, what's lambda? Now, in this case, you know you have 2 values of lambda. We are solving for how many axes? 2 axes. So that means in this PC, you have what? PCX and what? PCY. So let's solve for PCX first. That's small letter what? Small letter what? C is a subscript. It will never be the same thing. Now, moving on. Please look at this. Your first table you have in your table 24. Let me explain how to use the table. This is not the right table to use, but I'm going to explain which one you are going to use. Because if you open it, you see plenty tables. Now, okay, let me go and explain. The first row. Hello, look at your BS code. I need to enjoy. Values of PC. Small letter what? PC in Newton per mm squared. With lambda less than what? Lambda less than what? Lambda less than what? For strut of what? Now, let's look at it together. We are doing for our lambda, we are doing for x first, right? 1.5 PCX. So our lambda will be the one for what? X. Are you with me?
Yes.
So what's our lambda for x? 30.197. Is it lesser than 110? Yes. Is it lesser than 110? Yes. But our strut curve, is it A? No. Our strut curve for x is what? D. So go to the next table. Read what is on top. The next table says value of PC with lambda greater than or equal to 110 for a strut curve A. Does it satisfy it? Go to the next table. So now the next table says what? Values of PC with lambda less than what? 110 for strut curve what? Your strut curve for x-axis is what? Your lambda for x-axis is what? 30.97. Is it less than 110? Yeah. So this is the table we are using. Do you understand? Yeah. Now, you have steel grade and design strength. Steel grade and design strength. Have we looked for design strength for this question? No. So we have to look for it. So what grade of steel was given to you in your question for this question? Was not given. If it's not given, assume S275. Are you with me? I think I told you that now. So see, when you're assuming, you have to state it. You write it in your exam question, it will tell you every assumption you make, you should show it. So write it, assume steel grade S275, and go and get me your design strength. Oh yeah, let's do that. Do you know how to get design strength, yes or no? Yeah, please get your design strength. What? For design strength? You can't open your words. See, if you cannot scroll, that's not my business. I told you to print before coming. Better start scrolling. Answer me and get your design strength. Huh? That's 6 minutes already. I'll talk on. Please, what's your design strength? How do you get your design strength? Listen, before you get your design strength, you need to know your maximum thickness. 20.5, good. So you go to your table 9, 265 Newton per mm squared. Do you understand? If you don't understand, I'm not going to explain it to you. You'll go and understand on your own. Now, please listen. Every topic I take, you are only going to help yourself if I give you assignment and you do it. If you do not do it, there is no two ways about knowing this course. You have to practice and practice and practice, do 1 million questions until the steps stick to your head. Are you with me? So our design strength is what? Design strength is what? 265 Newton per mm squared. Go back to table 24. Go back to the table for this, what's it called? Now, our steel grade is what? S275, right? Sorry, my fault. Steel grade S275. Design strength is what? What's your design strength? Good. Now, your lambda. What's your lambda? What's your lambda for X? Go to your lambda for your table. Please, you know the table you are using, yes or no? For 30, do you have 30.97 on your table? In no case. Listen, in this lambda now, you have 30, you have 35, right? In no case should you have something like 30.91. You will not approximate to 35. Sorry, in no case you have 34.94 or something like that. You now interpolate, you approximate to 35. Do not approximate. There's a reason why it is point something. Now you calculate for them. So you must interpolate. Because I know some people who approximate so that you get your actual value. Are you with me? Yeah. So now we have 30 point what? That 30.97 is between what and what? Good. So this is our lambda. So what are we checking for here? Our PY is just 265. So for 30, what's our PY? What's our PC? What's our PC? Are you using the right table? What's your 253? Now, what's the actual thing we are looking for? 30 point what? That's what will be in the middle. So this is the PC that we are looking for, right? Right? Now, 35. So now, interpolate to get your PC. Interpolate to get your PC, please. Let's be fast with that. Interpolate to get your PC. Why are you looking at me? You are interpolating. Chukuma, interpolate now.
Chukuma, why are you
Interpolate. Now, this one is still for your x-axis, so that we can do our y-axis too and get done with it. Why are you not interpolating? Alright. Should I go through interpolation?
Yes. No, now.
Interpolation at the 200 level, but I'll go through it. I will go through it.
242.
Now to interpolate, two,
242.1.
that's impossible. You have 247, you have 247, you have 253. Your answer should be between this range. Now, listen, I'm explaining interpolation for people that don't know it. Now, listen, whatever you do on the left side of the interpolation, you must do for the right. Please settle down. So now, 35 minus 30. I'm doing this minus this minus this, divided by 30.97 minus 30. Now, you can do it any way you want to. Are you with me? We'll still arrive at the same thing. Just make sure that whatever you are doing on the left side is equal to the same thing you are doing on the right. So if you are taking this minus this for your numerator, make sure for the right side too, it is this minus this. Are you with me? So, but me, the way I take it is 35 minus 30 for the numerator, divided by 30.97 minus 30 for the denominator. So for the right hand side too, I'll take the same thing. This 35 minus 30 for the right hand side is what? 247 minus what? So for the denominator it will be what? PC minus what? 253. Because what I did here is what? 30.97 minus what? 30. So what will your PC be? If you want to know your correct answer, it should be within this range. It should be within 247 to what? 253. I said you got what? 251 points. So your PC is your PCX. Don't forget. Your PCX is what? 251.84. What's the unit? Your unit is written for you on top of that. On top of that table. Newton per millimeter squared. Now let's do for PCY on your own. On your own, what's the first thing you do when you get here? How will you know the table you are using, first of all? You look at your lambda. Your lambda is what? Is it less than 110? What's your strut curve for y-axis? C, or yeah, go there. And get me your PCY. Please, what you want to do, it should not take you more than 5 minutes. No need to talk. As long as you understand this. If you do not understand, call my attention. Hello. What's our PCY? Are you interpolating? Okay. You are interpolating between what and what? Good. And what's your 52? What's your 54? Now interpolate to get your PC. Are you done? Are you done? Anyways, you're going to be figuring out that PCY is equal to 207.78. Is that what you got? If you are saying yes, I know you've not done it. That's what you got. You didn't do it, so don't even. So now, do we understand? Do we understand up to this point? Our last step. Sorry, second to the last step. 7, 8. Now, what does it say? Step 8. What does step 8 say?
Calculate compression.
What does step 8 say?
Calculate compression resistance.
Plus 4.7.4. Plus 4.7.4.
Huh?
4.7.4. I gave you the last class. Compression resistance plus 4.7.4. Open it. Plus is in your BS code if you are just coming. Plus 4.7.4. I think I gave you assignments now for last listen. Did you do it?
Yes.
I will not mark your assignment too. Your assignment is just to give you a question to practice with. If you not do it, it's on you. Compression resistance. Now, like I said, if we actually did our classification, your column should not be slender. And if it's not slender, that means to pass class what? 1, 2, or 3. So what is the formula we use for our PC? So capital letter PC is what? Now, we have two values for this PC, yes or no? Let's do for PCX. For PCX, this will be PCX, then we'll do for PCY. Please get me both values. Get me both values, please. I think I taught you how to convert if you are doing your PC. What did you call your PCX is what? 34 3425 point what? 0.02 kilonewton. What's our PCY? What's our PCY? What's our PCY? Are you sure this PCX is correct? Give me a calculator, please. Okay, you're correct. Take. What's your PCY?
2825.8.
28 what? 0.81 kilonewton. Now listen. You have PCX and PCY, and you can only have one PC. Are you with me? You have PCX and PCY, but you should only have one PC. Now, your lesser value will always be your PC. Your lesser value between your PCX and your PCY will always be your what? PC. Write that down. So what will be our PC?
2825.8.
Now let's go to the last step. Step 9. Step 9. What does step 9 say? Kilonewton. If what? Please say it now. What's our FC value?
3280.
3,280. They said we should check if it is lesser than what? If it is lesser than what? Is it greater or lesser? So now, look at this. This is our FC. This is our FC. You know how we got FC now? This is our PC. And they said that for it to pass, FC must be what? Lesser than what? Is this lesser? So it has failed. So what does it stay in that same step line I gave you? Go back to what? Step 2, which is what? You pick another trial section. Now, this is where you are going to space yourself. Please. Oh, yeah, let's do it. It's like class work. I don't, okay. Why can't you space? I told you bring your BS code. Okay. Is it that, see, you can do it now and you can choose to not do it now. That's on you. What's your question? Femi.
I'm picking 3, 5, 6.
Yes, anyone in your UC. That's how for check. What you call it?